Hello and welcome to this new tutorial. Previously we defined the generator through our class G, which contains the architecture of the neural network inside the init function and the forward function to forward propagate the signal inside this architecture. And now that we have defined the class, we're ready to create as many objects as we want, that is, as many generators as we want. But we only need one, and that's the one we'll create in this tutorial. So to create an object of the class, we need to choose a name for this object, and the name we'll choose is netG, for, as you might have guessed, the neural network of the generator. netG, and then to create an object of the G class, well, there is nothing more simple. You take your G class, and then you add some parentheses. Why do you only need to add some parentheses? It's because in the arguments of the G class, we only inherited from the NN module, and we didn't input any argument. So basically there is no argument, and therefore there is no argument to input here, hence the only parenthesis. Perfect, and so in the flashiest of the flashes, we got our generator neural network. Congratulations, and now, as I said in the end of the previous tutorial, we need to initialize the weights the proper way to respect the convention of the adversarial networks. And to do this, we have the weights init function that can do that for us. So I'm quickly going to explain what it's going to do. As you can see, we start with the class name variable that is some kind of a research tool that will look for some names in the definition of a class. So it will look for some names inside this class, and the names it's going to look for are conv and batch norm. And since conv transpose 2D contains conv, well, it will find conv transpose 2D, and then it will initialize the weights to 0.0 and 0.02 for the convolution modules. And then, same for batch norm, it's going to look for any name in the class that contains batch norm, which are of course the batch norm 2D to batch normalize the feature map. And on each of these layers related to the batch norms, and inside each of these batch norm layers, it will initialize the weights to 1.0, 0.02. And remember, in each layer you also have some bias, and all the bias at the batch norm levels will be initialized to 0. So that's exactly what it's going to do, and it's using this class name trick to look for the convolutions and the batch normalizations inside the class to initialize these weights the right way. Alright, so that's how it works, and now to apply this function, we just need to take our generator neural network, which we've just called netG, and then we add a dot. Then we're going to use the apply function to apply the weights init function. So I'm just copying this and pasting it inside. Alright, and this will just apply the weights init function to our netG object, that is the neural network of our generator. Alright? So congratulations, we now have a generator, a real generator neural network. So basically we're done with the first big step of this implementation of the deep convolutional GANs, which was all about defining and creating the generator. Now we're going to move on to the second big step of this implementation, which will be about defining and creating, this time, the discriminator. So we'll do that in the next 3 tutorials. We will start by defining the class, then we'll define the forward function, and then eventually we'll create our discriminator object. Until then, enjoy computer vision!